are now.
All right. The first is pretty straightforward. If you go back to your original electrical book, you will find schematics just like the one I'm about to make. But the things you have in here are a compressor, a condenser fan, an evaporator fan, a 24-volt contactor, a thermostat, and a transformer, 120 volt to 24. For the sake of argument, it doesn't really matter all that much. Now, you're going to want your compressor, condenser fan, and evaporator fan to all come on at the same time, which means they have to be arranged in parallel. At this point in time, we're not going to worry about common start run. We're just going to express these as simple circles. Compressor, condenser fan motor, indoor fan. And we can connect them all together. They're in parallel now. But there's a little bit more to it than that, isn't there? We need a control system to control when this is on and when it's not. And that's going to involve a transformer. So now we've got 24 volts for our control system. And our control system is very straightforward. We've got a thermostat and a contactor coil. Now make sure you draw a cooling thermostat. Remember, this denotes a bimetal element. So as the heat increases and the bimetal element expands, it will close the switch, bring power to the contactor coil. Now these contacts are right up here. So with, if you were to make the indoor and outdoor fan the same fan, this could be the basic schematic of a regular window unit, easily. And this is the ladder diagram. There's more than one way to do this, and it still works. You can also make a pictorial diagram, but this is the quickest and simplest I can demonstrate here. Now, the next project, one little step in complexity, that's all. Next project goes like this. This is no longer the contactor coil. This is now S1. And let me just kind of tell you the criteria for the next project. It's of course the compressor, the condenser fan, the indoor fan, the contactor coil, the thermostat, the transformer, and a liquid line solenoid, as well as a high pressure and low pressure switch. So now the thermostat's going to control the liquid line solenoid. Well, what does a liquid line solenoid do? It's an electronically controlled valve that either shuts down or opens up the flow in the liquid line. So when the thermostat gets cool enough that it shuts down power to the liquid line solenoid, it closes. No more refrigerant can get through there into the evaporator, and the compressor is going to keep on running. So we've got to have a way to turn off the compressor now. And that's going to happen with this. We've got the low pressure switch. We've got the high pressure switch. And then we have our contactor coil. So what happens now is when it gets warm enough in our refrigerator, our walk-in box, it could just be an air conditioner still. This is going to come up and make connection and provide power to the liquid line solenoid. The liquid line solenoid will open, releasing the refrigerant in the liquid line and the condenser, and as it floods into the evaporator, creating cooling already, once that pressure gets up high enough that the low pressure switch closes again, the compressor will start. And that's how a liquid line solenoid is a control in both air conditioners and refrigeration.